Time to have some fun. Welcome back. In this video, instead of proving anything, we'll only be looking at spotting patterns. So this is the Pascal triangle I've drawn over here. You don't have to draw it yourself. And this is the Pascal triangle, but I've written it such that it looks like a right triangle. I've only shifted all these one and aligned them. And we'll be looking at as many different patterns as we can find in this. The first and most obvious pattern is, okay, these two numbers are to give 2, 2 and 1 are to give 3, 2 and 1 are to give 3, 3 and 3 are to give 6. Well, that's the definition of it, wasn't it? That's how we constructed the Pascal triangle, so that's not really a pattern. But the pattern is, okay, this Pascal triangle is symmetric about this middle line. If I drew some kind of line over here, so the left hand side and right hand side are mirror image of each other, 1 1, so there's 2 is inside the line, so there's 1 1, 3 and 3, 4 and 4, 10 and 10, then 5 and 5, 15 and 15, 6 and 6, 1 and 1, 35 and 35, 21 and 21, 7 and 7, and so on. So this is reflective property of Pascal triangle. What else can we figure out? Well, I can think of, okay, let me look at this one, because these two are same triangles, just written in different order. So the first line, or as I should call it, the first column is simply column of 1, quite boring, isn't it? Second column is 1, 2, 3, 4, 5, 6, 7 are those numbers which you know as the natural numbers. The next number, the next column is 1, 3, 6, 10, 15, 21. You might recognize them as a triangular number. So the first triangular number is 1, another triangular number is 3, another triangular number is 6, another triangular number is 10. So these are the triangular numbers. Or in other words, the sum of first few natural numbers. This is 1 plus 2, this is 1 plus 2 plus 3, 1 plus 2 plus 3 plus 4, as you can see here. The next number, the next column gives us the tetrahedral numbers. So if you draw a triangle, draw a tetrahedron, then the first tetrahedral number would be 1. The next tetrahedral number would be, this would be the base of the tetrahedron, the second triangular number, and if you put atop of that the first triangular number, you will get a tetrahedron. Not really great at drawing, but I'll try my best. So you would get some kind of tetrahedron like that. So 3 on the bottom and 1 on top of that. If you put the third triangular number as the base, and on top of that you put the second triangular number, and on top of that you put the first triangular number, you get the next tetrahedral number, which is 20, and so on. Now the next column, you might have already guessed. If we go into fourth dimension and put the first tetrahedron on the bottom, then the lower tetrahedron on top of that, then another tetrahedron on top of that, you will get the higher dimensional analogues of these numbers. So there is higher dimension in Pascal triangle. What else can I figure out? There's this nice identity, I like to call it the hockey stick identity, that I can see in the Pascal triangle. If you add 1 and 2, you get 3. If you add 1, 2 and 3, you get 6. If you add 1, 2, 3 and 4, you get 10. If you add 1, 2, 3, 4 and 5, you get 15. Now just over here, if you add 1 and 4, you get 5. 1, 4 and 10 gives you 15. 1, 4, 10 and 20 gives you 35. Same thing can be drawn in this side. If you add 1 and 1, you get 2, the diagonal. If you add 1, 3 and 6, you get 10. If you get 1, 2, 3, 4, 5 and 6, you get 21. if you get 1 add 5, add 15, you get 21. 1 and 6, you get 7. So there's this kind of formation in both this triangle and the another triangle. The last thing I want to tell you about this is, can you figure out the Fibonacci numbers? The Fibonacci numbers, if you don't know, the first Fibonacci number and second Fibonacci numbers can be defined as anything. I'm going to define them as 1 and 1. And the next Fibonacci numbers is the sum of the preceding two Fibonacci numbers. So next number would be 1 add 1, that would be 2. Next number would be 2 add 1, that would be 3. Next would be 3 add 2, that would be 5. 5 add 3, that would be 8, and so on. Can you find the Fibonacci numbers in the Pascal triangle? I warn you, it's difficult, but I hope you can find out. You can find Fibonacci numbers in this triangle, but I think this triangle would be easier to look at. Okay, the way you do it is you draw the diagonal shapes. So that's 1, that's 1, that's 1 add 1, that's 2, that's 1 add 2, that's 3, 1 add 3 add 1, that's 5, and if you go on, 1 add 4 add 3, that would be 8, 1 add 5 add 6 add 1, that would be 13, and so on. That's how you get the Fibonacci numbers. Hope you enjoyed this video. Thanks for watching. Please like, comment and subscribe.